Hello everyone, welcome to the NATS Maintainer Track Talk about the NATS stack. First of all, it has been a very, at least personally speaking, has been a pretty long conference. I've been standing on my legs for all day. I hope you're feeling a bit better. I didn't actually know that my legs were able to stand for that long. Anyway, yeah, talking about, again, a NATS talk, let's first do some intros and we'll get right into it. So first some intros. I am Maurice van Veen. I am from the Netherlands. Maybe any Dutch people in here? Or look at that. That's great. It's pretty funny. We have pretty much I'm a senior software engineer at Synadia. We are a remote company. We have pretty much people from all around the world, pretty much. So it's pretty funny when our French colleague can just talk French, and there are some Dutch or Belgian people. Anyway, that's fun stuff. Yeah, and so pretty much I'm a NATS project maintainer. I've been working a lot on the server the last few. Well, I've actually joined Synadia relatively recently, like a half year ago, a little over 9 months. But I've been contributing prior to that for years already. And pretty exciting as well, since prior to last KubeCon, I actually became the NATS ambassador of the project, which is still kind of exciting to me, but I don't know. Previously, I've been a software engineer. Yeah, fun fact, also being pretty much at the same time a teacher at the university, so I hope I kind of do a good job at presenting. And if not, let me know.
Awesome. Anyone from Colorado here? Nope, didn't think so. So my name is Jordan Rash. I am from the States. I am a software engineer at Synadia. My primary role there is I'm one of the maintainers on the NATS execution engine. How many people knew that Synadia was getting in the business of an execution engine? It's new. So we're going to talk about it a little bit today, not as a product, but as what features and perks it gets on top of the NATS server for free. When we started developing it, we found building a product on top of NATS gave us a lot of really cool features that normally as an app developer we had to think of that we didn't have to think of anymore. So we'll show some of those. And before this, it's cybersecurity and defense fields. So a bit of a different perspective. I came into NATS differently than most. But nonetheless, you get here, and we find that at Synadia, it's pretty much a unified vision, no matter what field we come from. So Maurice is going to talk to you a bit, and then I'll show you some demos.
All right, so first off, some NATS 101. Who's already familiar with NATS or heard about it? Okay, quite a few people. Also using it in production, or maybe also not yet in production? Okay, cool. Quite some hands. Pretty cool. So first, pretty much, kind of the boring stuff. What is the project? What is it all about? So next slide. So this is kind of a bold statement. So I'll try to get wrap a story around this. So kind of thinking back, it might sound strange, talking about this at a conference like this, but really long time ago, it used to be just you rent a server somewhere, you'd have one application, run one database, and that was it. That was your company, and it was so simple before. And well, in a way, because SSH into FTP, things have gotten a lot better since. But in terms of applications, are not that simple anymore. I don't know, kind of the use cases that we're hearing, and probably you also have various unique cases within your business. It's just really amazing, how relatively quickly, all of these applications have to be distributed in a way, or maybe they can't always have an internet connection if you're at the edge. But still, from this kind of initial perspective, the things don't necessarily need to be complex. And yeah. So kind of what does a current, or what might a current stack look like? So you have various technologies for reaching out to from one server to another. You might need some maybe you need some other patterns. So you kind of look around what other components are available. You search for a different component. You add it into your stack. but then still you're still missing something. Maybe it's observability or persistence in one way or another, and you're kind of adding multiple components. And to be honest, it's not like we're dissing on any project or something. It's like, because, and I think I don't need to tell you this, but all of these projects are just great. But it's kind of the thing that makes me think is like kind of all this general pattern of I need to add and just keep on adding more and more components, and things start to become complex. And kind of going back to that initial simple example of just one server or maybe multiple, but like your application, a database, things were simple, and the things you were working on were actually like maybe over 90% your own business thing, your own use case, the thing that you'd like to work on, and not necessarily like maintaining other things and it's kind of starting to look like most of the things that you kind of need to work on is like having lots of other components in there. And also the thing that you would like to do, I hope at least, that kind of also depends what you're working on. But if I'm mostly coming as a developer and engineer, I like to fix things for a business and what they're doing. So I'd like to spend my time on that, not necessarily on like any other system, and keeping that up. I'd like to I think you get the point. So kind of where do we come from in terms of like what do we have available right now? We think it's kind of these inherent limitations that you have. So things like the one-to-one communication, just adding all these layers in terms of like the components, not necessarily specific components, but like in general adding more layers of I have an application somewhere, I need to deploy it somewhere, I need to have it highly available, maybe in a cluster, I need load balancers, proxies, and the list goes on and on. Things are centralized and location dependent in a way, even though we don't necessarily need them to be. And if we're doing like an edge use case or like maybe a car is driving around it, I mean, it is location dependent in terms of like it's physically somewhere, but in terms of if you relate it to where the data center is, it's not static at all. So how do you then still figure that out? And it's just generally like multiple technologies that you need to learn, and not only as a developer, but also in operating it. And yeah, so kind of not necessarily going back to that initial example of like one server, a database, which was probably SQL at the point, I don't know, and like an application, and thinking about like what do we need nowadays for the distributed systems we're building right now. And how do we simplify that? And I think we've learned a lot, and also with the whole like containerization, etc. So things like, I'll need to check the slides because I can actually read it from there. So like services that are inherently just discoverable, giving you the flexibility to use any type of communication pattern. Do you need to reach one service? Okay, fine, you can do that. If you need to have like one request and you have multiple services of different types that need to answer, sure, then you do like a request many pattern. You don't need to send every application a different message. And things, well, how it relates to NATS, for example, decentralized, it doesn't need to be decentralized, but in a way where I could be the one hosting some infrastructure, and I could give you the keys to actually an account somewhere, and I could give you some I don't want to equate that to like being an AWS in a way, I'm not sure, but just in general, I can give you some keys to an account, and you can make users. I don't need to care about who needs to access your system, and I give you pretty much the ability to do anything you want in a way that I don't even need to know who your users are. I just give you some limits in terms of how much infra you can use. And things like intelligent routing and still having, like again, kind of that edge use case of you have data at the edge, for example, bringing your services, not sending your data up to the cloud, but bringing your services down to the edge to do local inferencing or like local, oh shit, I cannot mention AI, sorry. And of course, like the internet connectivity issues, even with like, I'm not sure how your experience was with the conference Wi-Fi, but especially on Wednesday, I was really struggling, like even loading the Google Slides. So anyway, I think that those things are changing a lot. So I don't think we'll be deploying on the cloud. Well, I think, well, we will still, no worries. But in general, things will be shifting more to the edge as well. And things like internet connectivity is not a given in such a place. And you probably, and it also again depends, like it depends on your use case and what you're solving for a business as a business. But yeah, and again, kind of what NATS provides a single technology to learn. Yeah, so I'm not a salesperson, so I'm not going to tell you that NATS is the thing that you need to use, and otherwise you're I don't know. If this talk just helps you in kind of rethinking, like where can I simplify my architecture? And I personally don't mind if you would be using NATS or you wouldn't, but I kind of make you think, like where can I simplify my architecture in a way? And maybe NATS can play a role in it, maybe not, but that's your decision. And again, I'm not a sales guy, but yep. So kind of why do teams love NATS? And like kind of there are these different kind of roles, and in practice, and it also depends like in which company you work for, and like these roles might be fluid in practice, might be more fluid in practice. But kind of for giving developers the tools to use all these kind of different communication styles, using persistence through key value stores, object storage, all with just a single API, just one technology to learn. Similar thing for architects, like how do you map the technology and the infrastructure that you need onto your business, and allowing architects to pretty much deploy infra or have infrastructure in multiple clouds, multiple geos at the and extending to the edge, and again where internet might not be available at some point. And also kind of giving the operators kind of the handles they need for like things like multi-tenancy, like the thing I mentioned, like I can give you the keys to an account and you can make users, and I can also give some keys to someone else and you cannot see what others are doing. And also, of course, similar important things like security monitoring and etc. So what is NATS? Kind of going towards like this simplicity theme. So it's a really small, it's one static Go binary that you need. It contains everything. If you want to cluster in the cloud, you have really like large workloads. You can use it. You can cluster it. You have access to persistence through streams, KVs, etc. But again, the same binary at the edge, the same capabilities that you can use for the connectivity, for the persistence, all of that is just available. And you will have the ability to actually choose how to use it and how it fits to your business. Yeah, and of course, it is so small because like no external dependencies. It supports many OSs, official client libraries, also community-maintained clients, and well, the Slack has already reached over 10K Slack members, so that's pretty cool. So going through this pretty quickly. We've finally done the NATS 2.11 release. Who has been waiting for this for more than a year? Well, I was. We finally are there. I'll go over it a bit quickly. We also, actually on Wednesday, we released a podcast that we did on it. It's way more details, and I'm just not going to be able to like fit it into this time slot. So if you're interested in these things and more kind of the design and like what went into testing and reliability, watch that later. But in essence, distributed message tracing, your topology can be very large, and where does your message actually go? Well, tracing is, of course, like an important thing. Per message TTLs is a new thing. So previously, with streams, you would only have like one max age. If you have a max age of an hour, a message would go away after an hour. If you want anything different, then no, sorry. You would need a different stream with a new max age. But now you can actually have per message TTLs, and you can expire based on whenever you need them to. Pretty obvious one, consumer pause, unpause, Jetstream consumers, you can pause and unpause them now, instead of like needing to shut down your application or having to change your application to actually pause consumption. You can actually do it as a kind of a management or maintenance point of view. And you don't really need to like adjust your application. Consumer priority groups is kind of this thing that we're going to build on more in the future as well. One thing that I'm not sure how, like where it's available right now in terms of, it will be in orbit, but one of the things that it will have is like, if you have multiple clusters across, for example, various geos or availability zones, and you have services local to also processing you need to do, but those services are overloaded, you have a way to overflow pretty much some requests to maybe a different availability zone or a different cloud or whatever to ensure the load is still so balanced appropriately. And batch direct get, previously you could pretty much only get multiple messages if you actually created a consumer, or you could like get a single message with one API call, but you never could get multiple messages in a lightweight way without creating a consumer, and now you can. So you can send one request to get many responses of like messages that are stored in your stream or in your KV, for example. And I kind of already mentioned this with Orbit. It's kind of this you might have heard, or maybe not, but kind of the thing is, with the clients, the official clients we provide, we kind of want feature parity across all of them, which is hard if you get like a contribution to any one of the clients, and we'd really like to say, yes, put it in, but then there's so much work also to get it in all the other clients, and even one obvious thing is like all the languages are different, and we're kind of trying to be idiomatic in all the languages. So there might be some things that work in Go or in Rust or whichever language, but might not work in another. And we didn't really have a place to put that contribution where we would like it to have it. But also from our end, kind of being able to iterate over APIs was pretty hard for us. And our solution is pretty much Orbit. So pretty much every language can have an extension to the official client. You can pretty much do anything you want. If anyone contributes, we can just accept it. Versioning and iterating over APIs is way easier. And eventually, once like an API is finalized, we can actually pull it into the client, and then we can actually be sure like it works properly, it's useful for all the clients, and then you can move it into the client. And once it is in the client, you actually can guarantee stability, and you don't still need to change the API. Final things with the NAC rewrite. So NAC is Kubernetes CRDs if you want to manage streams, key value stores, etc. That way. Did a rewrite. It has now proper control loop, also related to some changes that were in 2.11. And also support for key value stores and object stores if you want to create them, I believe. We also did a JavaScript client rewrite. This is now pretty much the different transports of Dino, Bun, browser WebSockets, etc. are now all in one repository instead of separate ones. And also, if you only need core messaging, you only need that package. And if you only need that string, you only get that package. So a bit more modular as well. Yeah, and with that, I'm going to give it to Jordan, I think. Yes, I remember the slides. I think you can talk as well. No? No?
Hey, so thanks. So for the rest of the slides, this is going to be less about our execution engine and more about how we developed a product dogfooding everything that server had. I'm just using the execution engine as a reference. If you have more questions about that, we can talk afterwards. First off, we have 3 slides on different ways to like configure NATS as a cluster. One of the most interesting things I've listened to Maurice answer this question about 100 times in our booth is like, what does our reference architecture look like? And the question is that it's really hard because it's different for every customer, right? You have retail that wants to be able to support a connection loss in their stores. You have things all the way out to the edge that need to be able to offload at certain times when connectivity is there. So the NATS server itself runs in 2 modes. One is a NATS server and one is a Leafnode. And with utilizing, it's the same binary, it's not like you have to deploy multiple things. Utilizing those and putting a little thought into your architecture really extends the concept of a cluster anywhere. We call, I think, a cluster of nodes, we just call that a cluster, and then we can do clusters of clusters, which we call a supercluster. So it's really whatever you can imagine, we can usually find an architecture for it. So this is just a simple demonstration of, you can see on-prem and connecting 3 clouds and that eventually reaches the customer via web or mobile. So you can imagine GCP, Azure, and AWS there also supporting on-prem with resiliency between all the clusters. Another one we see is the edge device being the customer and like stores. So we can have storefronts running small clusters that provide that, disaster recovery and that back up to each other while also reaching up into bigger clouds in the back end. So you can have like large clusters up in the cloud and all your stores reaching in. And that can be a typical hub and spoke type thing where you have a single thing and hundreds of stores reaching in. And the big one, the one we were demoing in our booth, if you came and saw it, this is kind of like AI at the edge. So we recently did a demo where we were able to do inference, model generation, data generation in 3 different clouds all over a same a NATS subject bus. And because the underlying layer was NATS, the messaging system was able to move between clouds real time, support model generation real time, support data gathering via camera or web app real time, all with the without downtime moving in, when nodes and clusters would go up and down. So it really does show that kind of like NATS can go wherever you want. And that's one of the things that we don't do is we don't try and define what your edge is. You tell us what your edge is. Because we have people where that mainframe's the edge, we have people where an ESP32 is the edge, and we have people where a phone is the edge. And our goal is to meet you where you're at. So I'm going to give you a brief review of what NEXT is so that we can talk about it as an application. But this is kind of how the NATS ecosystem was built. We had the connectivity layer. If you're familiar with NATS server, you've been using it. It's pub sub, it's load balancing, it's service discovery, it's all these things that make our connectivity easy. And then we overlaid Jetstream on top of it. That gave us KV, that gave us streams, that gave us object store. We could persist data, we could replicate data throughout our cluster. All these things came for free. And then we started building applications on top of it. And what we found when we were building specifically the execution engine is we didn't have to reach into our old bag of tricks. We didn't need a database. We didn't need a KV store. We didn't have to pull in everything. We realized, it's already sitting there waiting on us. Even from a security perspective, where you would normally have to do things like OAuth. Well, we have auth callout, which is the NAT server supporting OAuth stuff. We also have subject level security, which I'll show you here in a second, which essentially enhances that multi-tenancy concept, and it'll feel a lot like namespacing here in a minute. And the important thing to say is no code was written for that. We leaned on NAT server configuration for all of it, and you'll see in a minute it's pretty powerful. So going back with what Maurice said a second ago, Orbit. So Orbit was even new to our team. It only dropped maybe a few months ago. And we came in and we started to look to see what all was there. And things like Request Mini. We already had the capability to put out a request, listen for a bunch of responses, and then use some context and some timers and kind of do this ourselves. But what we found is a lot of people wanted to do that. A lot of people want to request, do scatter gather, request a message from a bunch of servers, wait some, expected amount of time, and then stop listening. So this simple Request Mini concept in the Orbit removed, I think, a few hundred lines of code and fixed 14 race conditions that we had, because we had written our own loop. And we were not closing our context correctly. This solved all that for us. So we found very quickly that the mini is better than the few when it comes to things like common patterns like request a scatter gather in NEX or in NATS. And then so that's the whole trusted code. It comes from a community, and many people are using it. So these bugs tend to bubble up a lot faster. And this was an exciting one. We only very recently, since 2.11 landed, we turned it on in the execution code, and we started using it to try and follow our requests. So one of the very first things we do when we deploy a workload is we auction an entire cluster, and we're like, who can take this workload? And it was you can imagine it goes out, the servers respond if they can. But what was pretty cool is we turn this on, And all of a sudden, we can start to see our requests travel through the cluster. So you can tell I live pretty close to AWS West, so that's where I ingress into our cluster. But then I have nodes in AWS or in Azure and GCP. You can see it traversing the gateways between all of them, going out, asking those nodes the same question and returning back. So this has actually helped us do a lot of communication-based troubleshooting on our end. And let's try a demo. Talk while I set this up. All right. So what I have right here is I have NATS running on the left, NEXT running on the right. NATS is running pretty much as bare as you can get it, all the default settings. And what we're going to see, thank you, is I'm going to do something as simple as deploying a workload. I don't know if I'm doing the logs, but you can trust me. So what happened was I deployed a simple workload. It's a counter, and I'm going to list the workload for you. And this all kind of works exactly how you would expect. You deploy a workload, you list your workload, and it's there. But the problem with a default server is if I go over to the other user and I request, you can also see my workload. So multi-tenancy is not working. Everyone can see everything. There are admin type commands you can also run that if you were to run those as well. Yep, that's not how you spell node. I do have one bit of security in there. All right. So those are admin type credentials that normal users, or admin type functions that normal users shouldn't be able to do. So now we want to lock that down. But what we don't want to go do is add a whole bunch of custom logic to our application. So let's address it in a NATS configuration. And what I'll do is I'll just show you kind of what I'm doing. So we're going to create 3 accounts here, an admin account and 2 user accounts. In the default version, it's pretty much one plain, no credentialing. But when you look down here, you'll start to see that on our control subjects, we're going to require that the account that you're using to do the request matches the account in your credentials. And this is what empowers all the security over like a NATS-based subject mapping. So with a little bit of architecture and making sure the subjects make sense, you start to get security for free. So if we do that, we'll turn NEXT back on. All right, we're going to come here. We're going to start the exact same workload. Oh, that's the wrong command. So I think I actually have logs dumping this time. So you can see the workload running right there. And now when user 2 goes to, when user 1 goes to look at their own stuff, they have permissions to ask what workloads does this account ID have. But no longer does user 2 have that. And you'll notice it happens so fast because that request isn't actually making it into NATS. The export that it has is not even allowed to do a request on that subject, so the server shuts it down immediately. And you'll see even when we go, so we'll even try and do the admin type functionality, it shuts down immediately because the users aren't allowed to do that. So what we pretty much demonstrated is configuration-based security that no longer has to be rolled into your application. The NATS server can do it all, which we found to be extremely powerful. And then I think we're just here. So it's all you. So yeah, thank you for coming out. Like, here are a bunch of links. We recently did an online conference where we had a bunch of great demonstrations. It's on our website. It's on our website. So if you go to synadia.com, You should see a link up top to watch that, where we had something like 5 hours of demonstrations of everything from 2.11 features to the execution engine running to another new thing we have, which is connectors, which is running on top of the execution engine, and pretty much all of the new NATS 2.11 features that you could hope to see. So if you have any questions, we're happy to have them. Feel free to send us your feedback, and thank you for being here.
One question, what is a workload? Could a workload something be that I can react on an event which is coming, I can subscribe, and then I can react? Can I how a pattern matching which events are coming, combining, and is that what you mean with the workloads?
So pretty much what workloads allows is multiple types. So you can run pretty much any type in terms of like you can run some containers. You can also you run, for example, JavaScript. We're kind of working on that. So you can actually kind of as a function as a service. I think that's what your question was about, or?
I think when it's integrated in NATS, it's something which react on events or can react, or it's triggered when an event is coming and these things.
So yeah, so the workload engine itself does emit events, so we are in the process of making it event sourced and making it a lot. So you saw a little bit of delay in the thing. It is pubs, it is request reply at the moment, but it is using streams to bring the whole event sourcing type ecosystem into it as well to be a lot more reactive. So using that is kind of where we'll get to the more declarative type workloads eventually. Right now it's very imperative. I hope I'm understanding your question correctly.
Yeah, I think so, yeah. So I want to call a workload or a Lambda serverless function, for example, if some event is coming or a specific event, so you have an event filter. If that event is coming with that
yeah, so you said if
matching,
there's an event on a NATS subject, can the workload be triggered?
Yeah, exactly.
Yeah, so that is actually how our functions as a service will work. We call them trigger functions. You'll run them, and they listen to pretty much a trigger subject, and as soon as you send some sort of payload down that, it'll execute the function and return it, kind of like pretty much exactly like a Lambda and a webhook, but all over NATS.
Okay, thanks a lot.
Absolutely.
Hi. One quick question. Did you work on any optimization of key value storage with NATS when it comes to listing items? I was trying to use NATS, and in my use case it would be very handy, but I find out that, for example, once you have 100,000 items in key value, it's really slow to list or compact the storage on the file.
Yeah, so we've been hearing this a lot, and kind of the thing that makes RKV unique is also kind of where this performance issue comes in. So having the ability to like the delete and purge markers that you have, which allows you to watch on a KV, but also introduce like this. So per message TTLs is one thing that will hopefully solve that. So you will not be needing to do any manual compactions anymore. So when you purge a key, you can give it a TTL, and then actually the data will just be removed, which pretty much let's see, but it should solve. You should not need to do manual compactions anymore, and it will be solved in that way. So you would just say probably you're using like a purge already because you're using the manual compaction. So you give it a TTL, and it will be removed automatically, and that should ensure that the stream is kept at a reasonable size, and it stays snappy. But yeah. So per message TTLs is like a feature that we're one use case was also being able to optimize this.
Okay, thank you.
All right. You had a question, or?
Yeah, just a quick one. So the workload thing you demoed, what's the difference between that and NATS Micro?
So that's actually all built on top of NATS Micro. It's the concept is to run NATS Micro, you build your thing, it has the micro, and then you have to run it somewhere. we're trying to replace that run it somewhere for you. So if you build your own NATS micro, instead of putting it in an EC2 or ECS or wherever, you can tell the workload engine, like, deploy this for me, and it'll go find a place to put it for you.
See, okay.
What we're not is another runtime. We don't need another runtime. We have too many. But what we are trying to be is a control plane for artifact types. So if you have an OCI, we know 50 ways to deploy an OCI. We can do it in the cheapest way for you based on some analysis. Or we can put it in Kubernetes for you. Or we can put it in ECS for you. That's the hole we're trying to fill. We're not trying to be another runtime.
Okay. Thank you.
Absolutely.
Thank you, everyone. All right.